G'day guys, and welcome back to another one of Mr. F&R's maths tutorials. Today we're going to be looking at reading graphs. By the end of this little tutorial, and once you've completed your task sheet, you should be able to identify the parts of a line and column graph, and you should be able to read data from them as well. Line and column graphs, although they look quite different, have similar parts to them. They each have a title, they each have axes labels, and they should each also have an even scale on the side. So what do I mean by this? Your title is always in the centre of the graph. In this case we're looking at the favourite colour of a number of students or the room temperature. The axes labels go on the x-axis across the bottom or the y-axis across the side. So in this case our y-axis is the number of students or the temperature, and our x-axis is the colour, the favourite colour of the students, or the time. Make sure with your labels, if they are something that we measure, like temperature, you have the units in brackets. And finally, the last thing they all should have in common is an even scale. If you look at the numbers going up the side, they should go up evenly. So 0, 5, 10, 15, 20. Or this side going up exactly the same. Across the x-axis in a bar graph or a column graph, quite often you won't have numbers, you might have labels. So red, green, yellow, blue and pink. Notice how these are in the middle of the bar graph. Whereas in a line graph, your numbers 9 AM, 10 AM, 11 AM, 12 PM and 1 PM are on the lines. And they again go up evenly. So they're the parts of a line graph and a column graph. Let's have a look at reading them. First of all, let's take a look at this column graph. The heights of 5 students were measured and the data was displayed as the column graph. We've been asked 2 questions. First of all, who is the shortest student? Taking a look at our height chart over here, we can see the names across the bottom, the heights up the side. Easy to find the shortest one. It is the person who has the lowest column. In this case, it is Donna. Now when you're answering these types of questions, it's always good to include as much information as possible. So we can say, for part A, Donna is the shortest student. To include more information, we can actually tell how tall she is. If we take this line from Donna and we go straight across, we can see that she is 100 centimetres. So we can say she is 100 centimetres. For part B, we're asked the height difference between Tim and Donna. We already know Donna's height because we measured that last. We find Tim, here he is, and let's have a look across the top. We take a line from the top of his column across, and we can see that it is halfway between 140 and 160, so here Tim is 150 centimetres. Donna, we already know, is 100 centimetres. So the difference between them is a subtraction. 150 minus 100 equals 50 centimetres. Now we could just leave it there, but quite often with word questions we like to finish with an answer. So we can say that Tim is 50 centimetres taller than Donna. There we go, and that's our answer. Notice how I didn't just put down for part A Donna and for part B 50 centimetres. To show your understanding, you want to include as much information as possible. Let's take a look at some line graphs. In this case, the temperature was recorded every 2 hours and the data was displayed in a line graph. We're going to ask again 2 questions. What time was the hottest part of the day? And we are asked to estimate the temperature at 2 different times. Again, we can see our title, our axes labelled, and an even scale going up the side and an even scale going across the bottom. The hottest part of the day is part A. Well, the hottest part of the day would be the peak of this graph, which we can see is right there. So we know for A, the hottest part of the day, that means the hottest time, was 2 PM. Now again, we want to include as much information as possible. So we're going to take this line across and find out what the temperature was. We can see it was 25 degrees. Again, I didn't just leave the answer as just 2 p.m. I put it in terms of a sentence and added some more information. Now we've been asked to estimate the temperature at 2 different times, 4 p.m. and 9 a.m. So let's find 4 p.m. along here. Here we go. We're going to take a line straight up, and we're going to take a line across. Now you notice that this dot here isn't quite on the line, it is just below the line, which means it is just below 25 degrees. Now we've been asked to estimate. So for part 1, just below 25 degrees would be 24 degrees. So the temperature at 4 p.m. was around 24 degrees. The word around there shows that we are estimating. We're not saying it exactly was, we're saying it was around. Let's have a look at 9 a.m. Now we can see along here these go up by 2, so we know that 8 a.m. is here, 10 a.m. is here, which means 9 a.m. must be in the middle of these two. We're going to take this line up, and then we're going to go across. Now we can see here we are between 15 and 20, and we're about halfway, probably just over halfway. So halfway between 15 and 20 would be 17 and a half, and we're just above that, so we're going to say around about 18 degrees. So the temperature at 9 a.m. was around 18 degrees. Again, we're using that word around to say that we are estimating. Now the main thing here is that I've drawn all over this graph, and that's exactly what we want you to do. So as part of our summary, we know that there are 3 main things. We should have a title, we should have axes labels, and we should have an even scale. And the last thing is, don't be afraid to draw on your graphs. This will help you when you're reading the values, and it actually shows you your thinking. Anyway guys, hope that was useful. Have a go at the task sheet, and let's see how we go. I'll catch you next time.